Señor, quisiera preguntarlo, ¿usted puede ver mi cámara?
Sí, claro, Henry, ahí te veo muy bien.
Perfecto, señor. Perfecto. Muchas gracias.
Bueno, ok.
Señor, quisiera preguntarlo, ¿usted puede ver mi cámara?
Hola, hola, hola. Henry,
Hola, buen día.
¿cómo estás?
Bien, gracias.
Tú vas a hablar con la cámara puesta, ¿cierto?
Sí, claro. Hago la presentación, claro.
Entonces, para ver si me puedes hacer el favor de activarla para ir acomodando todo, para que quede todo bien. Gracias. Listo, entonces empezamos en 5 minutos y terminamos a las 11:15.
Perfecto.
Ok, ¿me escuchan?
Sí, señor.
Sí, señor.
Do-
Hola, muy buenos días.
Buenos días, Henry.
Listo, ya vamos a empezar. Son las 10:40. Entonces, le aviso.
Perfecto. Bueno, muy buenos días a todos. Les doy la
Good morning,
bienvenida
everyone. I welcome you to the 7th International Congress on Design and Engineering, COLOMBIAMAR 2021. It is an honor for me, on behalf of the Corporation for Naval, Maritime, and River Technological Development, COTECMAR, to introduce the talk we're going to be listening to now within the competitiveness in the shipyard industry session. I am going to now introduce Vice Admiral Javier Diaz Reyna from the company Marlot. He's a professional naval engineering, a specialist in industrial technology and high management. He's also a master's in national defense and security with an MBA and PhD in process engineering from EAM University. He is an expert in production management, maintenance project management, and naval maintenance and construction, as well as research and development into modeling and simulation of industrial processes. In his trajectory as an officer for the Colombian Navy, he was in high positions around strategy, naval materials, president of COTECMAR, general inspector of the Colombian military forces, and today he's going to be doing a presentation on probability analysis for estimating productivity performance in a shipbuilding yard. I now give you Vice Admiral Javier Diaz Reyna. Good morning, sir. Okay, Henry, good morning, and thank you so much for your kind introduction. My name is Javier Diaz Reyna, a proud retired officer of the Colombian Navy, and I'm here to honor this appointment to do my presentation in the 7th Congress of Naval Engineering and Design. A probability analysis for the performance of a shipbuilding yard from a real system in Colombia based on experiences achieved by COTECMAR. Probability analysis for estimating productivity performance in a shipbuilding yard is the title of the work that I was privileged to share with Dr. Carlos Fajardo and Dr. Riola. These are the 8 items that within the allotted time, I will share the scope and the conclusions reached in this research project. Okay, allow me to introduce the context and the motivation of the work that I'm going to share today. I consider relevant to mention that this research is within the framework of the proposal that I presented as my doctoral thesis, whose main objective is the design and development of a simulation model for discrete events aimed at processes, which represented the shipbuilding model for our shipyard Cotecmar, analyzing probabilities and doing forecasts on projects never before taken on by this shipyard, and of course, turn that into a contribution to this digital transformation within this 4.0 environment. But above all of these motivations, there is one that is even higher than that. I want to make a contribution to this potential challenge of considering naval construction or shipbuilding for the next generation of frigates for Colombia within Colombia. We know that the current capacities are in the final stages of their life cycle. We also know that if we find the political willingness to face this challenge, the benefits, the technological, industrial, economic and social benefits for Colombians will be absolutely invaluable. The construction and the project for the OPV-80 vessel has represented for Cotecmar the main source of knowledge, experience, training, and learning curves, but also mainly, this is the one that has most significantly implied the capacity for building warships in Colombia. As we know, this vessel required about 1,100,000 man hours, 350 workers, 27 months of construction, 45 blocks, not exceeding 40 blocks, and a total displacement of 1,854 tons. Okay, within this context, the OPV-80 vessel constitutes the center of attention for acquiring information databases with the purpose of contextualizing and defining a simulation model, which accounts for Cotecmar's production system. It is also important to clarify that this work of modeling Cotecmar's production mainly revolved around the main production process. The human talent, the infrastructure, the design, and the materials were available components, but research lines were also considered for modeling and adjusting this to this computational prediction or forecast model. Information is important for facing the model, considering Cotecmar's constructive strategy. This is a document that reflects the manner of building the blocks, the sequence within which the blocks have to be assembled, the sequence for the outfitting, and we need to consider that that outfitting intervenes the whole of the vessel based on that structure, and also the assembly sequence of all systems on board. This information comes from an electronic mock-up from a software that is well known in the naval industry, which generates production data, production engineering data, and which makes the model a reality. Another important document is the real work schedule for the OPV-80 vessel, which, as we can see, included about 2,000 activities, of which 1,000 were dedicated to the construction of the ship. Now we can see that every single system and shipbuilding groups are included. And among those activities, we can see the time frames, the sequences, the critical pathways, and the moments where each event took place. This information is vital in order to conceptualize the model. Now, information regarding the methodology implemented. We use the Urquía and Martín methodology, which was proposed from Universidad a Distancia de Madrid in Spain, based in Madrid, which proposes 11 steps leading the modeler to the accomplishment of the design and the development of a discrete simulation model, which is focused on processes. Now, on this slide, I would like to show the seed of this modeling. Now, on the right upper corner, you will see the real sequence within which the OPV vessel blocks were arranged and assembled. And in the schedule simulation, we can see the beginning of the construction and the assembly of each of the systems on board, the construction groups. That leads us to generate a specific moment to start the processes and to turn this into a line or a sequence of events on the basis of a software selected. Now, on the right side, we chose the vessel dimensions, which we're going to explain. We will explain how we use that to do a mathematical formulation leading to predictions about the construction with different OPV vessel dimensions. Okay, the steel production line, we can very easily conclude that it constitutes the backbone of the construction of the ship. We start from cutting sheets of raw material. We turn that into previous components for the blocks. We create the blocks, and afterwards we do the assembly of the hull, which is similar to a giant Lego. Okay, this strategy of construction and these 5 phases are contained within COLOMBIAMAR's construction strategy. And when modeling, it generates a flow chart that leads us to think about the conceptualization of the model. We can cut profiles and metal sheets. We can build the blocks that will be turned into the hull and the superstructure of the vessel. Here we can visualize under the aforementioned criteria a conceptualization of this model, always taking into account the fact that the steel construction line is the central line of the modeling. Here I'm gonna try to use this
recording in progress
note-taking tool. And as we mentioned before, the block construction model is going to allow us to provide orders so that this system actually starts processing. The vessel will be finally assembled. We will wait for the outfitting and the hat outfitting works to be completed, and the vessel we will later on displace through the system, move through the system, so that the sea trials can then be implemented. This simulation model Okay, we're gonna try and delete some of these lines. Okay, so this simulation model was translated into a model of a specific software, in this case FlexSim, which led to a friendly 3D model. It actually allows for us to insert figures and provide animation so that we can easily understand it and so that we can easily interact with it. Now, at this point, we're facing the most important question of this research work. Okay, what is the data in terms of probability that we are going to enter into the model so that we can output stochastic responses which are typical of a project-based strategy, such as those used for vessels. Okay, there are 5 types of information. First, we take all of the databases generated from production performance within the steel line, determined in kilograms per hour per man. Now we can do some linear forecasts in terms of the hot outfitting, which represents activities that are related to welding components to the hull or working on the structure in order to add or annex or attach components to the hull. So we took some dimension-based components to reach a linear projection. In terms of the construction groups, which is the 3rd type of information, we have some mathematical quadratic regressions that were used based on data taken from these systems, be it propulsion or electrical systems, which were developed in other COTECMAR production lines. We know that COTECMAR has completed over 100 construction projects in its history, and there is information about the time frame of construction for other vessels, so that we can in a more detailed manner explain this. So we take information, performance information, from the steel production in kilograms per man hour, and we're going to link that to the weight and to the per day work hours and the amount of people who worked there. As we multiply that, we can get time in terms of days. But the probability exercise is based on taking all of these databases. For instance, here we have the cutting of the profiles and implementing some adjustment wave exercises until we get the kind of curve that adapts to this performance. Here we have a probability curve, which the software generates by means of a value within this formula, so that I can get an estimated time frame for the cutting of the profiles, specifically for one block. And for the 40 blocks, and also for each of these subsystems, we already have the first piece of information on the basis of probability. Now, the second one is for hot outfitting. This hot outfitting is comprised of linear lines relating a dimension of the vessel to be built with the OPV dimensions by means of probability distribution curves. Here I'm going to try to do an exercise. If we have the displacement of the vessel, we can get an estimated time for the outfitting, which is going to be implemented to the vessel tanks with a probability distribution assumed as normal, which generates the first question. Okay, what is going to be the standard deviation for this curve? Okay, let's do this exercise to see where we can get this from. Okay, so several observations were made in other exercise implemented in other environments. The State Department of the US did a study on the Harley series of ships. They did the Monte Carlo progression to try and get a normal Gaussian curve, and in that way acquire a variation coefficient that is going to allow for me to identify the performance and the expectations of response in terms of the shipyard production. For steel production, here we have a study by COTECMAR for cost estimations. They also applied Monte Carlo, and they did a variation proficiency. But for my case, the most relevant thing is to make an analysis on the steel vessel series, which COTECMAR has built most frequently, and all of these principles of Monte Carlo simulation were implemented to acquire a population of 3,000 responses of 3,000 potential timeframes for vessel construction. We did the limit problem applying a Gaussian formula on a normal basis, and ultimately we get a variation coefficient that is useful for representing the performance of the shipyard in terms of steel vessel construction or steel shipbuilding. Here we have the manner in which we get the normal distribution. We have for example, the possibility through this regression curve where we took the responses for this system construction on other vessels by means of the dimension of the cable length, and it will allow me to get an estimated time frame through a probability, a normal probability progression with data that allows me to calculate. Okay, so I do the same with each of the construction groups. Okay, so now we already have an approximate figure on the information given by the model to get stochastic responses so that I can repeat and make experiments. Okay, here we have 5 more minutes. Okay. Okay, here we have the information through which we entered the model. We did a large number of exercises in terms of the replicas. We got very appealing results, very close to reality. For the OPV 80 vessels, 150 days were spent, and the mean value of this experiment gave us a deviation of about 3%. But that is it is considered that the response values can be lower than 10%. We made some experiments by changing the production lines with 3 production lines by improving the shipyard conditions. And here we can see that a very positive response was acquired in terms of the reduction of the OPV type vessel construction. Okay. We developed an exercise, a very geometrical exercise, a desktop exercise to try and place this MECO ship that can become a candidate for new frigates in Colombia. We made a division by blocks in a very graphic, in a very rudimentary manner, but it estimates information directly related to the construction, to the COTECMAR construction strategy. We did an exercise, a simulation exercise. Okay, we can see it here. Okay, so it yields different values in terms of construction time, potential construction times for this vessel. Okay, we can see that the exercise generated 800 days with some attractive confidence intervals, and we were also able to identify the time frame for construction and assembly of each construction group. Okay, so I believe that we can now move on to the conclusions. We can draw some conclusions from this research project. The simulation model does represent the real system. With the information and the available databases, it is possible to predict on a probability basis the time for a shipbuilding project that has never been done before. It is greatly useful to continue with performance indicators for the construction and installation of subsystems or construction groups. We've identified restrictions. We've seen that we worked along the steel construction lines and we worked on the performance rates. The model contributes to cost estimation, specifically in terms of labor, and we've looked at different scenarios looking at the capacities and the performance of the shipyard. It is possible to update entry data and parameters according to the evolution of the shipyard's real conditions. There are a lot of research lines. We can see some such as 3D modeling specifically. It is specifically important to 3D model the movement of blocks and platforms. We can get a lot of information to make these processes more efficient. The development of new production indicators, identification of performance factors by type of construction. Right now we know that Cotecmar is building a scientific research vessel. Those data are going to be important to identify factors that will be applied depending on the type of ship. The modeling of all processes that are external to the building of the ship. That is going to be highly interesting for making this computational model much more robust and with more data. Finally, the information obtained from the simulation process is quite useful to estimate new shipbuilding projects in their early stages. It is very important to highlight that within the contract design phases, more deterministic methodologies are required. Okay, I finished right on time and we've completed the presentation. Thank you so much, Henry.
Aprovechando el espacio de preguntas, quisiera hacer dos preguntas que se encuentran en nuestro chat. Dice la siguiente: ¿cuáles fueron los principales desafíos en la generación del modelo de simulación para el caso del OPB?
Which were the main challenges regarding this? This question is definitely the most important, and we have to carry out the model using the information available. The information that was taken was not enough to generate a model. It was just done for statistical purposes. So the available information it has to be adapted to a simulation modeling. So most of the information was the one regarding steel line production. The other was required to adjust to historical information regarding construction, and definitely we have to work in these indicators. Okay, thank you, sir. Okay, another question, I think it's very interesting, this one. Do you consider this modeling can be a contribution to Shipyard 4.0? Of course, I mentioned it in the general context. Definitely, this is a contribution that is definitely the beginning to start computational modeling, to start an efficient production, a good estimation, efficient estimation of the projects. perfect, Admiral. Definitely processes, simulating processes are very interesting. We have to understand that we start from a real problem, and we have to come up with the concept modeling that represents that we are trying to finally translate to a computational model. And here we have a series of analysis, quantitative, qualitative, programming, simulation, how was really your experience to come to understand the real problem in translated to the scientific part. How was it really that experience for you to take this model, understanding the real problem, translate it to computational, keeping into account the real problem to make this translation? Henry, it was really a wonderful experience, beginning from when talking with people. We have information, a lot of information. We have data, but the interaction with people, with the experience, with the knowledge, with the studies, with master works done in different areas, it was a really valuable experience. I think I can say I got this from this exercise because I could put together all ideas and concepts, and I'm trying to understand what is possible to do, things that are not possible to do without having enough information. So I really value interaction with people, and I really thank the management of construction projects that they really supported. They were very friendly, and they really contributed for with all this, so that we were able to accomplish the purpose of this exercise. Okay, sir, we don't have additional questions, but I really want to thank you this effort in your study, in your doctoral study, focused, trying to come up with this modeling, contributing to COLOMBIAMAR in order to make progress in 4.0 industry. Definitely, these are very valuable steps that are required and that are necessary to take in order to know and implement the technology, and having the skills to know when to make decisions and use all these tools in order to make accurate decisions in order to consolidate our ship industry in the country. Very valuable contributions, sir. Thank you for sharing all this knowledge with us during this development of your doctoral study. Thank you very much. Thank you very much, Henry. And I'm really thankful for your invitation. Greetings to everybody, and let's enjoy this Congress. Thank you very much, sir. Have a wonderful day. Okay, thank you very much. Everything's going well so far. Okay, let's wait for the next talk. Dr. Raul Bonetti in 5 minutes will be starting. Thank you very much.
Un cordial saludo.
Muchísimas gracias.
Saludos.
Mr. Experience, sir.
Muchas gracias, señor.
Buenos días, ¿cómo estás, señor Raúl?
Bien, ¿cómo estás tú?
Good morning, sir. How are you? I'm fine, thank you. I can listen perfectly.
¿Será que puede bajar un poquito la cámara?
Can you move a little bit down your camera? Like this?
Me refiero a que un poquito más abajo.
A little bit down, more down.
¿Mejor?
Exacto ahí. Okay.
Yes, that's right. Perfect. Another thing, can you please share your presentation? Hello, Mr. Raul.
¿Cómo te encuentras?
How are you today?
Ahora que te veo.
Better now that I can see you. Okay, great. Same to you. Thank you, Henry.
Tener el gusto de ser tu moderador.
I'll have the honor to be your moderator in this Congress. My pleasure.
Bueno, como
Okay, as you know, it's 35 minutes,
la ponencia en total,
25 for the talk,
y 10 de preguntas, faltando 5
10 minutes for questions, before 5 minutes.
Yo solamente para avisar que
I'll let you know 5 minutes before the end to let you know the time is about to finish.
Perfecto.
Okay, perfect.
¿Cómo anda la familia, Henry?
How's family, Henry?
Muy bien, gracias a Dios. ¿Cómo se encuentran?
They're all fine. Thank you very much. How's everybody there?
Todos con salud.
We're all fine here, healthy also.
Que el próximo congreso ya pueda estar acá presencialmente como el
Hopefully, next Congress will be face to face, like in 2019. Okay, that's the wish.
Bueno, Henry, cuando quieras.
Okay, Henry, whenever you want to start.
Listo, sí.
Yes, yes. Okay.
Muy buenos días nuevamente a todos.
Good morning, everybody.
Con la serie de
We
ponencias
continue with talks about this competitiveness block in shipyard industry in this fifth engineering congress. My honor to introduce to you Mr. Raul Podetti. Raul Podetti is professional in naval architecture with master in engineering of Michigan University. His professional background has allowed him to develop expertise in the shipyard industry and the impact of green energies in the sea industry in Argentina. From since 2019, researcher in Buenos Aires University. And this morning, today, he's going to talk about competitiveness, naval competitiveness in Latin America. Mr. Podetti, welcome.
Muchas gracias, Henry, y muchas
Thank you very much, Henry.
a todos los participantes.
Thank you very much, all members of this virtual Congress. Hopefully, next meeting
Podamos ver
will be face to face. We'll be able to see our faces and provide us a nice hug as we all deserve. Okay, we are going to talk about competitiveness of industrial navy industry or shipyard industry, as it is called here in Colombia. It's named here in Colombia. This work we're presenting to you today, it's part of
por qué. Ahí está.
there.
Es la continuación de un trabajo que
It's a continuation of a work that has been done and we presented 2 years ago here in Colombia. And we committed with Carlos Braga, engineer, now head of the Argentinian chapter of Pan American Naval Engineering. And we committed to work in a book regarding naval industry in Latin America, analyzing it in different aspects, and we want to present it in Net Habana Copy Naval, hopefully next year. In the meantime, we were preparing this work. We made progress in a similar work. For sure, one of the most important naval industries in Latin America, which is the one of Brazil, presented last year in Brazilian Society of Naval Engineering. So the work we are presenting to you today is a little chapter of this new effort of analyzing the competitiveness of naval industry in Latin America and some of the works that we've been working on here in the component of engineering of Buenos Aires University, available in the website, industrianaval.com. Getting into the topic, the first thing we have to differentiate, make difference that within Latin America regarding naval industry, there are it is divided into two continents. On the one side, Pacific continent, and on the other side, Atlantic continent. Regarding their naval industry, they're very different. In the Pacific side is an industrial engineer where the members are from the state, they are members from the government, and in the Atlantic they are private shipyards. In the first one in the Pacific are more devoted to vessels and regarding military aspects, and in the Atlantic side the supremacy has to do with commerce, naval commerce. So it is also true this situation described before provides Pacific shipyard stability compared with the strong instability that goes on in the Atlantic side. So this way, just to mention, we can highlight one of the countries in the Pacific side. We can mention COLOMBIAMAR, as Peru, CIMA, Dianca. Which one of these with their characteristics? I can say the main ones, players and promoters of shipyards industries in each of their countries. In the Atlantic side, in Brazil, we can mention Brazil with a big, huge variety of private shipyards, very diverse ones, and only one big shipyard from the state, dependent from the Navy, with the historical naval arsenal, and it's the one of Brazil, the one that is building this series of new submarines. And regarding Atlantic countries, we have a naval industry that is in strong development in the fluvial sector. In Paraguay, and naval industry with the marine industry shipyard and some private shipyards. And in the side of Argentina, we have about 20 private shipyards, medium ones, small ones, and 2 shipyards that in history have been very important. The one of Santiago River in the 50s, Minister Manuel Garcia, shipyard of submarines in the 80s. Both have lost in the last 20 years, the importance regarding the output of the production. But we hope they can retake it. In terms of the evolution of the Latin American Navy industry, we can analyze it in function of their sales in millions of dollars of new construction, and we can see to year 85 from the 60s, we can say that the growth was launched. Firstly, you can see the green curve where you see a huge deployment in the 70s and 80s, and parallel with the small scale, you can see the deploy of naval industry in Argentina. You can see it in the blue curve, and the next years after the 90s, you can see Brazilian naval industry a little smaller, and how Argentina is going down. You very noticeable and never recovered. Beginning from 2000 year, this century, Brazil was a boom of naval industry oriented to our coast, and in Argentina continue with this underdeveloped naval industry, in which we continue to be due to bad political practices that use the vessels, and they don't promote development in industry. Beginning from the 90s, rest of Latin America industry has progressed in part by the contributions of Chile, Colombia, of course, Paraguay, CIMA in Peru, and in certain way Uruguay also. lastly with their contributions. And if we compare shipyards from the state and the performance of these shipyards, we see that the ones of the Latin America in the Atlantic, or the ones from the state, represent 10% of the quantity of units of shipyards in the region, and only 1-2% of output measured in terms of economical value. But in the Pacific, they represent 40% of the amount of shipyards buildings, and they represent 70% of output. And on the other side, the Latin American shipyards from the States are very similar in their relationship, the European ones, and the Pacific shipyards of the state in the Pacific in the region are very similar to the Asian ones. So if we compare the total shipyards regarding competitiveness measured in employment, generating shipyards by millions of dollars vessels, we see the ones of Latin America the most competitive because they use less resources by $1 million of vessels built. Something similar, less difference happens in Asia and in Europe. And regarding profit, benefits regarding sales, also private shipyards in Latin America and rest of the world are the ones of more profit, the ones in the ones of the states, and that shows that there are a lot of relationships with other regions of the country, a lot of to improve regarding competitiveness, shown in competitiveness regarding employment. Now, talking about competitiveness of the naval industry, we are going to try to differentiate analysis of internal factors and external factors. And this is a kind of maze in which internal factors in this jigsaw have to do with the levels of salaries and also delivery times, which are keys regarding competitiveness, quality, and also productivity. Regarding productivity, we are going to analyze the following aspects. On the one hand, there are a lot of concerns to measure productivity, and the most common way is to measure the amount of hours manned regarding tons built. The best case we have found regarding in Latin America industry at the end of the 80s in Brazil with 75 hours manned in measuring CGT. In that time, Korea was already low, such as 45. But this productivity measurement generates certain doubts when we start talking about its application in fishing, vessels, washers, supply vessels, patrol vessels, where precisely this type of ratios don't have the same applicability of the one of when we talk about big power vessels. Other complications this ratio has is the difficulty of measuring and compare between countries the type of productivity of naval industry. Therefore, we try to find a common ratio regarding types of countries and types of vessels, and we found that precisely there are two aspects: employment and value. Employment generated in the shipyard and the price, cost of vessels built is a ratio that, as we talked before, it's an indicator. More homogeneous in productivity has, of course, its limitations, but here we see throughout last 30 years, in the last 30 years, the different countries that we're showing here, they have all a tendency, a similar tendency, and in particular, the two lines, the central lines, the green and blue, representing Argentina and Brazil cases. They are located in an average value of a ratio of 20 employment for 20 million, which is higher of the average of the countries we are analyzing, but they're not values that are impossible to reach or to improve. It's interesting to see how in this ratio we see a tendency of reducing this ratio, which is an indication of the improvement of the naval industry worldwide. So it is also true because of the technification and the impact of not only robotization technology, but also digitalization of production. But also there's an interesting factor that many countries, many developed countries start to increase also the percentage of outsource jobs regarding shipyards. And there used to be more concentration in shipyards. If we see this Russian model in the 50s, it was disassembled more. The big spread of outsourcing regarding the number of people working in shipyards. So this ratio goes down if you are measuring the jobs within the shipyards. Continuing, one of the main factors regarding productivity in naval industry is precisely the one of learning curve. And we find that in the best time, Brazil was within this curve. Brazilian naval industry was in 85%, which means that Brazilian naval industry shipyard in Brazil was double their output, and it was going to improve 15% their competitiveness, productivity. In that moment in Asia, the learning curve was 70%. That means it was improving double in percentage that in the best of the cases in shipyards in Brazil. That really shows the tendency of improvements in productivity. In order to get the benefits of productivity, it is required specializations, work in series, volume of production, and continuity.
Okay, to look at these four aspects, we're going to study three typical cases in Latin America: Brazil, Argentina, and Chile. Okay, in Brazil, the specialization clearly is market-driven, and it aimed at the oil and gas and offshore industries. In the case of Argentina, it was the fishing vessels and the river transportation. And in Chile, it had to do with developments for the Chilean Navy. In the first case, there was a serious construction of offshore supply vessels, and particularly the Wilsons and Sons shipyard, leading to productivity enhancements that were markedly measured with relevant outcomes. Now, in the case of Argentina, the construction of trawlers, as well as convoys of barges, both tugboats and push boats, those were cases that we developed very successfully at Sanim, the shipyard that I managed for a number of years, as well as the Punta Alvear and the Rio shipyard that actually reached very high productivity levels for these types of vessels. As for the other types of vessels, years back, the Alianza shipyard was actually an exceptional case in terms of high productivity levels. As for Chile, the case of offshore patrol vessels built at ASMAR for a number of years also provides a clear example of productivity, which, although it wasn't exactly an example in terms of series, it was definitely an example in terms of design. Now, as for volume and continuity, in the case of Brazil, we clearly have a high volume in the case of Brazil and discontinuity. As for Argentina, the volume is medium, the discontinuity is absolute. And in the case of Chile and many other Pacific countries, the volume is medium to low compared to Brazil, but they have the big benefit of continuity. As for external factors, we can see that taxes are a very important external factor for competitivity. As for Brazil, by the late 90s, the ships built by Brazil shipyards for the domestic market were 40% more expensive than those imported than external offers. That same shipyard building for imports only reached a 5% of excessive price. As for the exchange rate of the currency, that's a factor that can completely change the competitiveness, which is something that we shipyards have no influence over. In the 90s, we were producing container carriers for Germany at our small shipyard in Argentina, and that contract came to an end because overnight the exchange rate was multiplied by 5, and it was absolutely impossible to continue with this type of action. Okay, another factor is the government's attitude towards the support of in-crisis shipyards. In the case of Asia, we know that in the face of a crisis, the government supports and safeguards all of the profits in terms of productivity, which shouldn't be lost due to the crisis. In the case of Argentina and Brazil, is totally the opposite. Every time there is a crisis, all the work accomplished is thrown overboard. Something we have to understand is that competitiveness is not something natural in our countries. It's not like the business of farming, like the exploitation of natural resources. Industrial competitiveness is artificial. The word artificial comes from the word artist that has to do with forceful and creative work of man. And that's the explanation why Japan and Korea have reached exceptional levels of competitiveness, despite the fact that they have no natural competitive advantages for shipbuilding. The political continuity in these kinds of situations is a key factor, not to mention the competitive economic environment. Therein, we actually look at the Industrial Competitiveness Performance Index from the UN, and we can see that the 10 top countries in Latin America are in a position where we have lost 10 positions, 10% in terms of international industrial competitiveness. This implies that the industrial environment around our shipyards is not really helping us in the same way as it's helping other countries. Finally, competitiveness is tested in the export market, and it is within that market where we have to look at ourselves to see exactly whether or not we're being competitive. There are clear niches of industrial performance in Latin America, such as the fishing industry, offshore oil and gas, and inland waterways. where we have to worry about a safeguarding of our resources and so that we can build ships to do our work. Same thing with dredging and port services, as well as offshore patrolling, which is basically the defense vessels that we have at hand, and undoubtedly all of our naval industries can implement this. And in the case of Chile and Argentina, which are countries that are close to one another, there is the Antarctic logistics, and new synergies lead to new opportunities in our shipyard industry. I want to thank COLOMBIAMAR and COTECMAR, organizers of this event, for the opportunity of sharing all of these thoughts, all of these studies, all of which are available for consultation and download. Thank you so much. Okay, dear Raul, thank you so much for this presentation. It shows a continuity that started off 2 years ago, focused on the Argentinian industry, and now it has a further reaching scope. And as part of that, we have a question. And this is the question. On the basis of your study, what recommendations can you give us to increase the competitiveness of the Latin American shipyard industry? Okay, the recommendations are basically those that we showed here. If I had to choose one of those recommendations, is the same one that we should be giving to those who are trying to compete within the in the Olympics. If you want to compete in the Olympics as a sport, the most important thing is to do exercises, to practice, and in doing that, it is necessary to have the opportunity for practicing. And that's the most important thing within the environment. Particularly, our governments have to allow for us to do that. They have to allow for working continuity and to support us, particularly at the beginning, so that those who are already more competitively developed will not kick us out of market, and they should allow for us to become better sportsmen so that we can ultimately compete in the Olympics, which is the exporting competition. Okay, Raul, we have yet another question. Okay, how do you think we can lead the shipyard companies to develop their efficiencies and grow on a regional basis? Okay, in this regard, we can say a million beautiful things, but they're actually difficult to implement. We have to be very clear and forthcoming in saying that we are a region, but every single country competes with the others and against the others, and it's good that that's the case. And it's good that among shipyards within a country, there is competition. So facing these kinds of scenarios from a technological and commercial perspective is a positive thing. However, there are things where we can complement one another. For instance, there is active participation in these kinds of conferences where we look each other in the eye. Very soon we'll be able to share hugs. And the most important thing is our developments and concrete projects, as well as studies and programs. And there we have specific opportunities. In addition to that, the generation of clusters, for instance, in order to exchange parts and components for vessels, that could also be an extremely interesting aspect of things that I believe is what I can contribute in that regard. Okay, Raul, fabulous. I would like to highlight 4 aspects which you mentioned during your presentation all the way to the end, with a focus on the learning curve. You highlighted the importance of specialization, work in series, volume, and continuity. and you showed the examples of those three big countries with a consolidated industry. In addition to that, well, you've mentioned a lot the term competitiveness, and on a regional basis, every country competes with others, but we can also complement one another. As for Colombia, around those aspects, working series, continuity, volume, what can you recommend in terms of what you know about our country? Okay, I don't know too much about the needs of Colombia, but the other day I was precisely attending a conference about aspects related to dredging in Rio de la Plata, and there is a huge concession project coming up in Argentina. And in that conference, which we gave in Colombia and for all of Latin America, we talked about the opportunities in terms of river transportation. And I believe that Colombia, since it is one of the countries with the highest opportunities regarding inland waterway transportation, it has very, very significant opportunities for specialization, which are ideal for serial construction at high volumes on a continuous basis. There are clear opportunities there with Brazil, Paraguay, Argentina, and Uruguay for complementation, because we're talking about rivers with similar characteristics in terms of low draft and the type of cargo being moved, which is basically low unit value commodities such as ore, grain, and fuel. Right there, we have a clear opportunity for cooperation, specialization, serial work, volume, and continuity. Okay, Raul, perfect. We have yet another question. Okay, what do you think about the focus on sustainability as an element for industry competitiveness? Okay. The issue of sustainability is a key factor. As a matter of fact, today present, none of the research projects that we are developing falls outside of this issue. I would say that I don't know if I can specifically talk about the impact of competitiveness, but most surely we can say that there are huge opportunities for our industries with regards to the use of energy, as well as the transportation of energy. Right now we're working on the development of river ships, hydrogen, LNG, bio-LNG, with low draft and the possibility for carrying these very fuels to the inland regions of Mercosur, south of Brazil, Bolivia, Paraguay, by way of river. So I don't know, actually, because I haven't thought about it too much. I don't know what the impact of competitiveness is with regards to the impact on the volume of new types of vessels being demanded, being required, particularly in Argentina, where our shipyards have always had to compete with used or second-hand vessels, which are governments allowed to enter tax-free. So it's difficult to compete with those. But specifically, clean power vessels have to be built as new because there is no market for obsolete vessels against which we have to compete. That is a possibility to try and keep going again, and so that we can become more competitive on the basis of volume and continuity. Okay, Raul, thank you so much. I would definitely say that this talk has been very productive, very satisfactory. It's provided us with lots of knowledge on the Latin American context, and it's generated high value within this Congress, which is our objective, to generate value and keep pushing forward, because what we want to do is to develop our industry. Thank you so much for your contribution, and we hope we can have an opportunity for a future Congress once we overcome this pandemic situation, and we appreciate your contribution again. Thanks from Colombia, and congratulations on that conference. Thank you.
Perfecto. Entonces vamos.
Okay, great. So we are going to wait
2 minutos para
about 2 minutes
de la última ponencia
to start the third and last session of the morning within this competitiveness block of conferences, and then we'll keep going. Okay, Edgar, morning. How are you this morning?
Aló, ¿me escucha?
Sí, sí, perfecto.
Ok, muchas gracias.
Le voy a pedir el favor que comparta su presentación para
Can you
ir.
please share your presentation so that we can set up the system?
Vale, si logran ver mi pantalla.
Sí, perfecto, se ve bien.
Podemos ver, Edgar.
Excelente, gracias.
Listo, Henry, yo te aviso. Dame un segundito.
Perfecto, quedo atento. Estimado, estoy atento a la confirmación.
Listo, permíteme un segundito, ya te
I'm
termino.
waiting for confirmation.
Listo, compañero. Vamos a empezar.
Vale,
Okay,
perfecto.
let's get started.
La serie de ponencias
Okay, we continue with the series of talks prepared for this morning session
de la industria astillera. A continuación,
about
tengo el gusto de
shipyard industry competitiveness. I am pleased to introduce engineer Edgar Mulford, who works for the company Shuttle.
ingeniero electrónico
Mr. Mulford is an electronic engineer with a master's in oceanic and naval engineering,
y desarrollo
expert in technical support, development and research, as well as project management, sales engineering, as well as consultancy in automation, as well as the management of structural projects and predictive engineering. He also has experience in field work, integration of electronic equipment, sea trials for high-speed vessels, experimental analysis of offshore platforms, as well as knowledge of transfer in the maritime industry. Right now, he's a sales engineer for Shuttle Colombia. His talk is going to be on hybrid propulsion system by Shuttle for the worldwide shipping industry. Eckhart, welcome. Okay, Henry, thank you so much. Okay, I want to thank all attendees, particularly the organizers of CDIN, for inviting us and for making for this space so we can talk about this exciting industry, the maritime industry. Okay, as a prelude, I would like to highlight the fact that this year, it is the centennial of our company, Shuttle, which makes us very proud and keeps on motivating us to continue working for the maritime industry. What started back in the early 1920s in a barn back in Germany has successfully become an active global company with 14 subsidiaries in almost every continent and is now the leader in azimuth propulsion within the worldwide maritime industry. Although our technological facilities in Germany, we have supporting facilities all around the world, and from our headquarters here in Cartagena de Indias, we provide support in terms of sales of new equipment for new constructions, as well as for overhauling of service vessels, as well as post-sale support, predictive and corrective and maintenance work, both on board and remote, as well as the supply and the logistics around spare parts for units, in addition to training, among other services. Okay, with regards to the constant technological evolution on the basis of the challenges put forth by the market day in and day out from the departments of hydrodynamics, electrical, engineering, particularly at Shuttle, we have been developing technologies regarding the maximization of propulsion technologies for vessels. For instance, gears with higher torque, better sealing systems, more efficient clutch systems, energy efficient systems, as well as digitalization, automation, control, energy efficiency. And within the framework of the Industry 4.0, we've also been developing interesting technologies implemented in the service of the efficient operation of vessels, always looking to minimize operational and maintenance costs, as well as maximizing the lifespan of our assets. Now, a good example in the development of these systems is the electronics on board, which can acquire real-time data on the operational systems for propulsion and steering by means of a cloud tool through big data, Internet of Things, artificial intelligence, and decision-making software can allow for analysis and evaluation of systems towards the optimization of such systems. Although the optimization of power and propulsion systems is the focus of designers, manufacturers, and other stakeholders in this segment, we can see that the influence of fuel consumption, gas emissions, the irradiated fluids, maneuverability, maintenance and operation in terms of cost for shipbuilders. All of those are interesting fields too. Experts indicate that worldwide, the maritime transportation industry needs to reduce its environmental impact, and it's been foreseen that the the carbon emissions will increase by 50 to 60% by 2050 if we don't take any measures with regards to maritime transportation. It's already contributing with 15% of global nitrogen oxide emissions, and that's why IMO is taking measures to try and reduce these greenhouse gas emissions. In this case, IMO challenges all stakeholders within the industry to find solutions or develop and integrate more efficient alternatives from the energy point of view in order to fulfill the greenhouse reduction goals by 2030 and 2050 by means of guidelines or toolkits, both for vessels and ports, with the aim of promoting these strategies. As a good example, we can find in our ports, such as the PSN port in Brazil, which is giving discounts to vessels that have energy efficiency instruments, and those initiatives are no doubt very interesting, and they will be more frequently used within Latin America, and that motivates shipbuilders to try and access all of these technological tools. The idea is to generate a disruptive idea that can contribute to minimizing costs, OPEX, fuel consumption, and generate a more energy efficient alternative. So we developed the side drive, the shuttle side drive system, which is based on the optimization of the upper gearbox in our propulsion systems, which configures a system with 3 power intakes towards hybrid synchronicity. Okay, there is a main power intake and 2 auxiliary power intakes. Although the development was based on integration with electrical engines, with hybridization, the optimization of this upper gearbox led to the mechanical hybrid system, which is named Side Drive M, which is comprised by an axis line coupled to 2 propellers, both starboard and port side, using a main engine with a standby engine with when there is no need for high static traction or drive. In terms of fuel consumption, there is a reduction in hydrocarbon emissions, and that can also have an impact on the overhaul time for these engines. In this configuration, there are 3 profiles. First, the standard operation, where engines and the associated propellers, there is maximum power and the lowest consumption of fuel, which is when the vessel is on standby. The 2 engines are controlled by means of synchronicity at maximum drive and low fuel consumption within a hybrid synchronous system operating the firefighting pump. This system is in the process of being patented. As an additional characteristic, we can say that it can be set up in different modes of control with regards to the power drive. And in the case of the firefighting system, it is possible for it to be controlled without the need of other components or expensive additions. In terms of the hybrid mechanical system, it is required for the engines to be high-speed engines with enough torque for the operation. Looking at the loading of the 2 propellers, the propellers have to be fixed pitch, and the gearbox has to have a hybrid setup with gears. The synchronous access should be included, as well as the on-off system that allows for it to engage and disengage. Now, to complement the standard operation mode, which is conventional, that's where we need the maximum propulsion energy. The synchronous system is disengaged, and every engine controls their associated drive. When the vessel is in transit or on standby, one of the main propulsion engines is off, and that alternately leads to a lower number of working hours with a cost reduction. The main engine, if it's still functioning, its fuel consumption is quite efficient, which reduces fuel consumption as well as emissions. Unlike a conventional tugboat, with two engines working on a light basis or on a conventional transit basis, where both engines work at low RPM, at a fairly low RPM, it is not fuel consumption efficient. And the idea is to promote these kinds of initiatives. For the case of firefighting system, the main engine is disengaged and is used for driving the firefighting pump, which leads to the system functioning without any additional investment in components such as controllable pitch propellers. And it still allows for the firefighting pump to function. Regarding control, a standard shuttle control is used through a synchronous button on the switchboard, which only activates when the lever position is at 0, which is different from the scale, and the integration of this system with the vessel autopilot is possible. We can say that shuttle, in collaboration with strategic allies, is generating a series of cases of study to look at alternative power options and the potential of this system. I can present this case. Why I have a hybrid system for tugboats. The biggest potential of this alternative is for these operational profiles where robust engines as well as high power is necessary. This is subject to short periods of time, which necessitates this robustness in terms of operation. That's why this kind of alternative is very significant, and it justifies these types of development. In this case, we consider a conventional port tugboat with two diesel engines, 2,000 kilowatts, between 1,600 to 1,800 RPM, with a number of annual operation hours of 2,000 and average annual hours for transit standby of 150. As we look at the specific consumption, fuel consumption curve related to the diesel engine associated, we can observe the relationship between the power and the RPM within the case that I was just showing. Now, in this case, we can show the curve when one propeller is configured, when there is a hybrid in tandem scheme, and the relationship between that synchronous model and the power provided by the engine or one of the engines controlling the tandem system. We can see that here, with the power provided at the point of intersection between these two curves, we can define the fact that this transit or standby mode, the vessel can navigate up to 8 knots on average, with about 1,100 revolutions, with the capacity to steer both propellers with the same engine. Now, in terms of response, we could see a speed of around 10 knots with an engine speed limit of 2,400 RPM and around 7 and 8% of fuel savings due to specific fuel consumption in this hybrid mechanical model.
Caterpillar, por ejemplo, por su
As an
parte,
additional example, Caterpillar reported an analysis different benefits regarding the shuttle side system operation, and in total, their estimation established around 50,000 euros a year for a period of 25 years of life cycle related to fuel saving of 42,000 euros a year and maintenance cost of 6,000 euros a year and reduction of gas emissions in relation to fuel saving between 6 to 7%. In relation regarding these results and motivated by these kind of initiatives, disruptive initiatives in Europe, Arcot Sport in Denmark, shipyard Usman, they built a tugboat. They built a tugboat, ASD with IMO TIR motor and 60 capacity of 12.5 knots, which let's say was recently launched, and it becomes a reference framework worldwide. The same in South America, the shipyard started in Brazil, launched an initiative the project of building both tugboats with diesel motors of 2,500 kilowatt and estimated velocity of 12.5 approximately. These four boats have configuration of upper gearbox. Let's say they set in synchronous mechanical or hybrid mode. We'll start with a tugboat, and with this will be a reference for the rest of the fleet. And let's say this way we can think Sea Drive can improve their balance of CO2 emission more than 500 tons of reduction of CO2 during its whole lifetime, and reduction one of the highest rate of reduction of CO2, and that's one of the reasons of global warming. So this is very meaningful. It has the capacity of reduction of CO2, and that's why companies like Shuttle, everything related to this kind of equipment, it's contributing to a better quality of the environment. The rest, let's say, as a summary, we can say the Sea Drive M system, let's say, allows reduction of engine hours of function, which contributes a reduction of maintenance cost, besides a more reduction of or noise. Since one of the motors or the engines off, so less life maintenance cost maintenance due to the clutch, the hydraulic clutch. It's there and it needs compressed air. So let's say it is possible to update firefighter modes in an easier way. The design of the boat, it's without without changes. The Sea Drive system can be integrated in any place. Propulling systems of the boat are also without changing. In the mechanical, diesel, conventional, no electrical components or additional optimizations are needed. Just a line for the synchronization and the clutch. So the captain and the crew will receive a tugboat without any needs of any special cost or any electrical cost, and so it's a very cheap solution regarding implementation of a hybrid system with electrical engines, motors. So let's say this is pretty much it, the message we wanted to transmit. Thank you very much for your attention. I'm I'm open to answering your questions. Thank you very much, Edgar, for your presentation. Here in our chat, I have a question. It's like this. When do you expect to launch this product to the market? This product's already in the market. I showed in the reference. It is already in Usmar vessel in Denmark and in startup vessel. It has this setup, and we hope the launch will be beginning 2022. So the first reference is already in the market in Europe, and the next one will be launched in South America, in Brazil, in the next few months. Thank you, Edgar. Next question says, have you done designing regarding electrical proposers and integrators? Yes, let's say technology. The technology started from the electrical perspective regarding all the topic of hybrid components. As you mentioned before, the upper gearbox has been designed to integrate electrical and motors and all regarding setup of generators. And besides, we have as reference, and yes, let's say it started with that development, and it was implemented, this alternative of mechanical solution, seeking for a cheaper alternative, but all the developments are thought to use the two kinds of setups, the one that is more adjusted and the one responses better to the environment. Okay, thank you. Another question is, it also lost the steps of variable proposers. Okay, but variability is not lost. What you do is you control the two propellers the way you do it in a system, let's say conventional system. Simply, it is cheaper than in other kind of variable setups or configurations, because when it comes to controlling it just with one connection, with a synchronous, you avoid all costs associated to this system. And because all the advantages it provides, you have 5R, it provides, you use all the structures you can find there. What are the ranges, our ranges that you offer? It's 1,000 kilowatts, and I have to 2,500 up to 3,000 kilowatts. Okay, this is the last question we have here in the chat. I don't know if you would like to contribute anything else, or if not, we will be finishing this talk. Okay, Henry, thank you very much. Okay, any questions you have, any requirements you have, I'm here open to answering and helping. And I don't know if in the event you have all my information as a speaker, but you can find us as Colombian Shuttle. Anything you need, I'm at your service. Thank you very much, Edgar. With this last talk, we finish the morning talks. Thank you very much, all the members, all the Admiral, Reyna, Dr. Raul Podetti, and you, Edgar, thank you very much. These 3 talks really contributed to competitiveness of the ship industry, and how we're making progress in this 4.0 industry. All of you, thank you very much, and we wait for you for the next countries, COLOMBIAMAR 2021. Thank you very much for your presence here. Thank you very much. Okay, Edgar, thank you.
Muchísimas gracias. Muchísimas gracias a todos.
Thank you very much.
Todo salió perfectamente bien. Gracias.
Perfecto, muchas gracias. Entonces, recordamos que
okay, I want to remind you of the afternoon session. It will start at 2 o'clock in this room, in this block design. Okay, thank you, everybody.